So we have this LC circuit again where two capacitors are in series. Initially, left-handed capacitor was charged to voltage of V0 and then switch was closed. We need to find the time dependence of voltage in both capacitors. So only one capacitor is charged in the beginning. So again our approach is going to be similar what we did in the previous 4.98. First we are going to write the differential equation from KVL. Then we'll try to get the equation in a single variable and we'll solve the equation, put conditions and get our answers. So let's assume variables. So initially the left capacitor was charged to CV0. Let's say after time t, Q charge has disappeared from here and it is collected here. So charge on this capacitor is CV0 minus Q, on this it is Q, and let's assume the current to be I. So let's write KVL in this loop. So CV0 minus Q by C minus LDI by dt minus Q by C is equal to 0. So we have two variables here, Q and I. So let's get rid of I. So I we can write as dQ by dt. So we do that and we have got our equation in single variable Q. So you can see this is equation of SHM where coefficient of Q is omega square and this term Q minus CV0 by 2 means CV0 by 2 is the mean value of charge. So on this capacitor we know initially the charge was 0, and if this is the mean value that means peak value will be CV0. So this charge will completely go on this capacitor and then again it will completely come on this capacitor, and that's how the oscillations will take place. So again we have this equation in Q. Q is the charge on this capacitor and we know initial Q is 0 and we can see the mean value of charge is CV0 by 2. Sorry, I think I said that amplitude is CV0. No, that's not the case. Amplitude itself will also be CV0 by 2, which is the mean value because initial Q is 0. So in phase diagram we can see that initial Q is 0 at t is equal to 0. Mean value is CV0 by 2. So extreme value will be CV0. So equation of this motion of charge, this variation of charge will be CV0 by 2, 1 minus cos omega t. Now for right capacitor we need to find the voltage. So voltage is Q by C. C is a constant. So we are writing in this form, so we can put the value of Q here. So we put that here and this is our answer. On left capacitor voltage is CV0 minus Q by C or V0 minus Q by C. So again we'll put the value of Q here and we'll get the voltage on left capacitor. So you can see here when on the right capacitor the voltage is maximum. So then when cos omega t is minus 1. Then here voltage on left capacitor at that time will be 0 and vice versa. When here the voltage is maximum, here voltage will be 0. Same with charge because voltage is proportional to charge. Alright.